Hello and welcome to Young Minds versus Physics. Right now, in this video, we are going to discuss about motion of center of mass. In the previous classes, we dealt with center of mass, its location, based on the vector location, vector form, and as well as in the coordinate system we have seen, and for continuous mass distribution of various objects like straight rod, circular disc, circular ring, semicircular hemisphere, solid hemisphere, hollow hemisphere, solid cone, hollow cone, right? All this is already done in the previous classes. Those who have not watched them, you can just subscribe and then look into the previous videos whichever are posted in this particular channel, right? So please do subscribe and share with your friends and watch the video till the end so that you won't miss the important concepts, right? This channel mainly aims at making you have to approach towards the problem, right? So all the best, go ahead. And now, motion of center of mass, it can be categorized under two cases. One is when there is no external force acting and when there is an external force acting. That means when net external force is zero, like whatever the state of the center of mass is there, it will be continued. Like let us see the example here which is on the screen, right? So there is a cannon where it is carrying a shell inside it, and center of mass at rest, okay, with respect to the system. With respect to the system, it is at rest, right? And now as the shell is projected out, right? So now here shell is moving out of the system, right? As the shell moves with some momentum, now the cannon is also being moved back, right? It obviously, it automatically is pushed back because of the momentum the shell gained. With the same momentum, the cannon is again pushed back. So therefore, what is happening here? The net momentum of the system is the same. Whatever previously, if it is at rest, and with the same momentum, that means now the net momentum is going to be zero. When there is no change in the momentum of the system, obviously there is no change in the position of center of mass. So center of mass remains at rest here, right? Before, if the cannon was moving with some speed also, with some velocity, right? And now as it is moving, if this is done, that is the explosion is done, right? Or the shell is projected out, even for at that moment also, right, the net change in the momentum is zero and hence will continue to move in the same manner. So that means, because this, like when the shell is exploded, that means when the cannon gives out the shell, there is no external force acting on the system. Hence, these internal forces are not changing the state of center of mass. Right, now let us see another example to understand. Now, here is a wrench, and this wrench is projected with velocity v naught. Now, a body as a whole, completely body as a whole, is under the influence of acceleration due to gravity. Is it not? And it is initially given some velocity in a particular direction, and the resultant of those two is not zero. Thus, what is happening under the influence of the gravity, and because of the initial force that we have given to the body, so the body as a whole takes a parabolic path. Right. Now, when the body as a whole is under the influence of the external force, then the center of mass is also under the influence of the external force. Right. So, therefore, along with the body, the center of mass also experiences that acceleration, the acceleration due to gravity. So, that means everywhere you can have that G, effect of G felt on center of mass. Therefore, center of mass also moves along with the body. But within the body, right, within the system, if you talk, that means within the range, right, all the particles may be having complex movement. You can see the direction of the wrench changing everywhere. So the particles inside the wrench are having some complex movement, but whereas the center of mass is the same within the wrench. That means within the wrench, the center of mass is at rest. Within the wrench, the center of mass is at rest. Suppose in place of wrench, if you imagine a shell, then the center of mass of the shell is at rest. Even the shell is rotating, like flipping, whatever it is. The motion is very complex. All the particles will have, but the center of mass will have the same motion. That is the path taken by a projectile, which is a parabolic path. So the path of center of mass remains the same until an external force disturbs the particles. Now suppose if the shell is exploded at this level, like along the path, what happens? If it is not a wrench, if it is a shell and it exploded on the way of its journey, right, on the way of its path, right, so what happens? So this is internal force. Explosion is because of the internal forces, not the external force. Therefore, the particles may scatter, but the center of mass will continue along the same path. Beautiful. So this is how you have to understand center of mass. Now let us see, hold on for a moment and let us see the examples and the concept behind motion of center of mass. Now in detail about motion of center of mass. See, center of mass, as we have seen already in the example in slides, it's a state of rest, or when the center of mass of a system is moving with a certain velocity. What is the meaning of that center of mass of the system moving with some velocity? Means when all the particles in the body, that means when the body as a whole is moving. Suppose if you take only one single body, where the body is of course system of particles. Now as the body is moving, center of mass also moves, is it not? Yes, center of mass also moves. That means when the body is moving with a uniform velocity or a constant velocity, then the center of mass also moves with the same constant or uniform velocity until an external force is applied, right? This condition retains until an external force is applied. Now when you talk about center of mass, usually we talk about the system of particles, right? Within the body, particle will be colliding with one another, or like all the particles will be randomly moving and they will be hitting each other, right? So suppose one particle hits the other one and the other one gets displaced. This is what you will think, right? So when it is displaced, then the particle location is changed, then the center of mass should also change. No. Why? Because when one particle is imparting force on the other one, the second one also makes a reaction force on the first one also, right? That means whatever the changes which are taking place in those two particles annul each other, cancel each other, and the net will be remaining the same. So therefore either the net momentum or like the net force remains the same. That means internal forces. That means the net internal forces together will become zero. So that is the meaning of like until an external force is applied. That means internal forces, whatever they may be, internal collisions, whatever they may be, internal changes, whatever they may be, that are taking place inside a system is not going to affect either the location of the center of mass or the motion of the center of mass. Right, that means if the center of mass is at rest, suppose if the center of mass is rest, let us discuss about a bomb. There is a shell, like, so suddenly it exploded. Its center of mass remains at a point, then now all the particles which are scattering from the shell will move in such a manner. This is not a rule what we are doing. This is observation what we made. Right? So we are not telling all the particles of the bomb to move in such a manner that the resultant net force is zero, or the resultant momentum is going to be zero, because initially the whole system is at zero. We are not telling them. Right? That is how the system is. We observed and then we tried to understand. Then we developed a concept on it. Now we are learning the concept, and now after this we will proceed to apply this concept in the problems. Is it not beautiful? So now what happens if the shell is like, if all the particles in the shell are like this, right? And suppose if the center of mass is here. Now when it explodes, all the particles will move in different directions, scattering themselves. And if you observe it, what happens here is the net momentum is going to be zero, keeping the whole system, like that means the whole system previously is at rest. That means the net momentum of the system is zero. Yes, now also, even though the particles are scattering in different directions, the center of mass remains at the same point. That's the beauty. Really, that's the beauty in nature, where all these concepts the humans are able to understand, and then they brought us to us, and it is made very easy now to understand and interpret the things. Right. So this is how the center of mass remains constant. Now suppose if you say that if some person had thrown the shell, now the shell is supposed to move like this, right? And now it is moving, right? It is moving in a particular direction, like this is the actual path that we assume. That suddenly, like, the bomb exploded. The particles will be scattering in different directions, but the center of mass finally will be along its path. That means this internal, why are we saying about it? That when the bomb explodes, it is not an external force which is acting on it, but it is because of the internal reactions that are taking place. It's only the system itself is exploding. Thus, the center of mass will continue in its same path. Right? Beautiful, isn't it? Likewise, you can talk about, like, suppose if there are charges, like on a frictionless surface, if they have a mutual attraction towards each other, when they move towards each other, also center of mass remains the same, because it is internal movement. It is because of whatever the reasons which are there inside the system. Here we talk about these two charges are two particle system. We call that to be of two particle system. As an example, here another example also we can say, two men standing on frictionless surface and pulling each other. Right? That means if two men, whether they are pulling each other, like when they are pulling each other also, if they move either towards each other or when they move away from each other also, this is center of mass of the system of those two people will remain the same. Here what are we considering? Frictionless surface. Why? Because friction is an again external force. Like suppose if the friction is acting, and again we have to think of it in a different, under different conditions. Right? So therefore, when you talk about motion of center of mass, first of all we must understand how center of mass behaves. Right? How center of mass behaves with respect to other particles in the same system. Did you get my point? Yes, how center of mass behaves with respect to the other particles in the system. So when one center of mass is moving in a particular direction, in a particular path, it will continue to move until there is no external force. Right? Whatever may be the internal changes that are taking place, because the net change is going to be zero. The net momentum is going to be, the net change in momentum is going to be zero. The net change in force is going to be zero. So the net change is going to be zero. So did you get my point? The change, you have to keep that change word in mind. So the net change is going to be zero when there are only the internal forces which are taking place, or the internal collisions that are taking place. So thus internal forces can never change the state of motion or the rest, whatever it is, of the center of mass. Center of mass will be in the same state. And now, so this is which is a very, very important theoretical concept that should enter into your mind. So when we talk about motion of center of mass. So those who want just can make a note of the examples. Anyhow, these are all available in Singage, GRB, and of course NCERT. In every book, almost all the books, you will see these examples. Okay, if you want, note it down. Now the point here is, when if F external is not equals to 0, that means there is an external force acting on the system. Maybe there may be a number of external forces acting on the system where the net external force is not equal to 0. That means there is a net non-zero or a resultant non-zero external force acting on the system. If that is the case, then there will be a change in the position of particles, as well as there will be a change in the position of center of mass. Right, so therefore now let us see how to understand it. Right, let us suppose that center of mass at any instant of time is xm is equal to m1 x1 plus m2 x2 so on, divided by m1 plus m2 plus m3. So where these are all particles and these are the x coordinates of the respective particles. Right, so similarly you can write ycm, zcm and everything. Right, you can also write YCM, ZCM and all that. Right. So now we are taking only one example. Of course, ultimately you can talk about the other things also. Right. VCM. Now what is velocity of center of mass? If there is a change in the location of center of mass, then the rate of change is velocity, is it not? So therefore you are going to differentiate this one. dxcm by dt is VCM. Right. So now suppose if complete mass of the system is given to you, then you can replace it with capital M. Or if that is not given, you can add up all the masses and then you make it a capital M. It's up to you whatever you do, and it depends on the problem. So I am taking this one common out. Now M1 into mass remains constant. It is not going to change in this scenario. Now dx1 by dt plus M2 into dx2 by dt and so. That means it is the rate of change in the location of the mass M1. It is the rate of change in the location of mass M2. So there is a change in position. So that rate of change in position is said to be velocity. So when you talk about velocity of center of mass, this will become the velocity of center of mass. Right. So in now the respective particles also will have their own velocities v1, v2, v3, so on. So m1 v1 plus m2 v2 plus so on divided by capital M, or sum of the masses of each particle, of all the particles, is VCM. Or VCM can be written as summation as sigma mi vi by sigma mi. Right? Very clear, very easy, very simple, very direct. Right. Now when we talk about acceleration, so when we talk about acceleration, rate of change in velocity, if at all there is a change in velocity, then only there will be acceleration. That means F net should not be equal to 0. That means external force, whatever the external force is there, there should be a non-zero external force acting on the system. If so, then there will be a change in the velocity of the center of mass. Then the rate of change in velocity is ACM, that is acceleration of center of mass, which is of course by symmetry you can write it as m1a1 plus m2a2 divided by m1 plus m2 and so on. And summation is given as sigma miai divided by sigma mi ACM is equal to. Now if you say that this ACM is because of the sum total of internal forces and external forces. Right? If at all you think like that. Now let us suppose that if there is an internal force acting on a particular particle. Right? So suppose two particle system is there. So one particle is experiencing some force, and because of this there is a force acting on the second particle which is opposite to it. So they act in such a manner that sum of these two forces is going to cancel each other and become 0. That means when you talk as F internal plus F external as sum of is the result, or it is because of this you are having an ACM, then from this discussion you can say that F internal forces are not going to affect the motion of center of mass. It is only the F external which is going to affect the motion of center of mass, right? So now net forces become 0. Then ACM is also going to be 0. When ACM is 0, then F internal what we say is 0. Suppose if there is an external force acting, then definitely ACM will be there. Thus we can write ACM, that means acceleration of center of mass, is not because of the internal forces but because of external force, that is F external by M is ACM, or M into ACM, that is the total mass of the system multiplied by center of mass acceleration, gives you the net force acting on each and every particle, and this is equal to F external. Beautiful. So all this discussion is for what? Only one simple statement, that internal forces cannot affect center of mass, whereas external force impacts, and the result is that there will be a non-zero acceleration to the center of mass, right? So please note it down. Now let us try to understand center of mass with the help of one numerical. Okay, one problem we will see, and then we will conclude today's topic. Right, so now a projectile is fired at a speed of 100 meters per second at an angle of 37 degrees with the horizontal. Okay, right, perfect. Where sine 37 is equal to 3 by 5, cos 37 is equal to 4 by 5. You know it very well, right? So now at the highest point, it breaks into two parts. So that projectile, you can think of it to be a shell, right? A bomb which is splitting into two parts here, right? So now, and how the parts are divided? Are they into equal masses? No. They said the mass ratio is in 1:3 ratio. Okay. So are they moving in exactly opposite directions? No. Let us read it. The smaller is coming to rest exactly at the same point. That means at maximum height, the smaller particle comes to rest. That means there is no momentum given to the first particle. That means from law of conservation of linear momentum, when there is no external force, the momentum is conserved. Okay, from that concept you can say that the total momentum, whatever the shell or the projectile or the body is having at maximum height, with the that momentum will be continued with the bigger mass, is it not? So that will be there. That means now the bigger mass moves with the complete momentum of the complete body. Where? Why? Because the smaller one is coming to rest there. That means the momentum there becomes 0. And what is the concept here? When there is no external force acting, the net momentum should be the same. Yes, at that instant, whatever the momentum that the body is having, the same momentum should be there for all the momenta put together. So the momentum of first particle is 0, the momentum of the second particle is ultimately the momentum of the actual shell or the body. Right, perfect, beautiful understanding of the problem. Now, find the distance from the launching point to the point where the heavier piece lands. So now here the concept is, where is the heavier piece landing, right? So now try to understand the concept and see how to draw the diagram. So the diagram here is like that, it's a shell which is projected at an angle of 37 degrees with the horizontal. Now at maximum height, it is splitting into two particles. So one particle is coming to rest. So what will happen? Will it stay there, saying hi and hello to all the particles which are there around it? No. Now it comes exactly under the influence of acceleration due to gravity. That is gravitational force of Earth. It is not having any velocity because of the projection. Is it not? Because it has come to rest. Understand this point. If you understand this point, then the problem is done. Right. So it has come to rest means now it is not having any kind of motion which was given to it before. Now it is at rest. Yet rest because means now it is only under the influence of gravitational pull of Earth. So therefore, this particle moves, falls freely now. It falls freely because its velocity here is 0. It falls freely under gravitational force, and it falls exactly at the midway which is supposed to be maximum height of a projectile. It is exactly at the midway between these two, right? That means where half of range, what we call as half the range, right? So therefore, I'll write the x coordinate of this to be r by 2, right? So comma 0. Anyway, suppose if I wanted to write the y coordinate also, I'm taking it to be 0. Right. So now it is r by 2 comma 0. Right. So now what is happening? Now the concept here is there any external force acting on this for the, is it the reason of explosion is any external force? No. By itself it exploded. That means the reason for the explosion is internal forces, not the external forces. If at all there is an external force acting, some students will be asking me always this point, like saying that, ma'am, but it is already under influence of gravity. Yes, it is under the influence of gravity. That is why the path is like this. If not, it would have gone like this, right? It would have taken this path only in which direction we have projected. Right? The whole system is under the influence of the gravity. Now also, even after explosion also, it is under the influence of the gravity. But the reason for the explosion is not gravitational force, right? The reason for explosion is internal forces. So the internal forces are not supposed to change center of mass path. So therefore, the center of mass will continue in the same path which is supposed to be there before explosion. That means the coordinates of this would be r comma 0, where r is the range of a particle, like which is with 37 degrees. Right? And what is the velocity here given to be? Velocity is given to be 100 meter per second. It is already given in the problem. Right. Now what happens? Since now this mass, this particle, now as this is falling and coming to rest, and here the center of mass does not change. That means obviously the other particle should go and fall at such a place. At such a place, let me say that it is Ex comma 0. Okay? Because we don't know. This is what we have to find out. In such a place that the resulting center of mass of these two particles is at r comma 0. Beautiful. Fantastic problem this is. Right? So now what is that? What do you have in hand is you have r. You have r by 2. That means you have xcm, you have x2, you have x1. You need to find x2. Beautiful. Right? You know the masses. Here the mass is in the 1:3 ratio. If you take total mass to be 4m, then one is m, the other is 3m. I can take it like that, right? So therefore, I have my x1 here, xcm here, x2 here. Now the mass here is m, the mass here is 3m. Isn't it? Right. So what is that we have to find is r by 2 and r. What is the range of a projectile? Range of a projectile is u square sine 2 theta by g. U square sine 2 theta by g. So therefore I will write it as 2u square sine theta cos theta. I am splitting sine 2 theta into 2 sine theta cos theta by g. Right. So 2 into 100 into 100. This is u square into sine 37 degrees. It is 3 by 5. Into cos 37 degrees. It is 4 by 5. Divided by acceleration due to gravity. Approximately we will take it to be 10 because it's easy to cancel here. So if the problem is an option like multiple choice question, you can see the approximate result and take, if at all the examiner is taking here it to be 9.8. Okay, so you can easily see that one. Right, so this is the result of it, and if you cancel everything like this and this, right, by 25, this 25 goes 4 times here, so 2 4s are 8, all together, put together we are getting it to be 96 into 0, so 10, I'm sorry, 960 meters. So what is R here? R is XCM. So I will write it here XCM. Very good. Now what is X1? Therefore, now x1 is equal to r by 2 is equal to 960 by 2 is equal to 480 meters. So now this is x1. You know xcm x1. Find out x2. x2 is equal to, or rather, very easy to say, xcm is equal to, take the actual formula, m1 x1 plus m2 x2 divided by m1 plus m2. So that means here m2 x2 is equal to m1 plus m2 into xcm divided by, is it so? Am I doing anything mistake? Right, so this is m2 x2 is equal to m1 plus m2 into xcm, right, minus m1 x1, right. So this is the formula. You wish you can just substitute, everybody can go by their own method. And now here this is m1 plus m2 into xcm, that is 4m, xcm is 960 we got, minus m1 is m, x1 is half of this one, that is 480, right. So that is m2 x2, or x2 is equal to, this whole divided by m2 is 3m. So m is common everywhere, and then simplify the whole thing. So you will be getting it to be 1120 meters. So where is the particle landing? The particle is landing at a distance of 1120 meters. 1120 meters. Clear? So this substitution part and simplification, you follow your own method, but the concept is important, right? What is important here is concept. What is the basic concept that you have to keep in mind? There is no external force acting. The reason for explosion is not external force. Therefore, the internal forces cannot change the path of center of mass. The center of mass will continue in the same path even after explosion. Clear? So that is the basic concept. Now, understood the concept? Yeah, please note it down, and please subscribe if you have not yet subscribed, and share to your friends. And after, that means from 1st February, right? From 1st February, we shall discuss all the important, the most and the important questions that you are supposed to know, right? Almost all important problems as well as the previous year question paper problems. We will take the analysis and we will go with, so that this session may help the children who are preparing for 2021 mains and NEET, right? Okay, see you again.